Hackers broke into a City of Austin road sign and changed the public safety message to warn drivers of zombies.
Het leukste is, als mijn foto op zo'n bord terechtkomt. Dat ben ik. Staat hij er? Staat hij er?
Residents in Dallas had a rude awakening Friday night when 156 emergency sirens wailed throughout the city, and officials are saying the sirens were triggered by a hack.
There's a bullseye next to the name. Makes sense since the store and 40 million customers are targeted.
Do you plan on swiping your card?
No.
You're paying with cash?
Yes.
It is the biggest hack in the history of the world in terms of scale. Yahoo's had an information breach that's affected almost 500 million accounts.
U.S. officials confirmed to Fox News that Russian hackers, possibly directly tied to the Russian government, hacked into State Department and White House computers.
There are new allegations this morning of a serious breach of American military secrets.
That's right. A confidential report first obtained by the Washington Post says Chinese cyber spies gained access to the designs for dozens of major U.S. weapons systems.
Hello everyone, and thanks for coming back, and today we will be talking about the security development lifecycle. Okay, this video will be divided into 5 different videos. The first video will talk about Microsoft SDL training through implementation. The second video will talk about Microsoft SDL verification through response, the SDL optional tasks, and SDL for Agile. Third video will talk about the OWASP Top 10. Fourth video will talk about threat modeling. And the last video will talk about penetration testing. Okay, so what are application security risks? So you have your threat agents, and they will do an attack on where they see a weakness. And from that weakness, they can get control of a certain function that will impact the business. That's basically what a hacker does and how they exploit a weakness and create a threat for the business. Now, there are different types of threat agents. So if the attack vector is very easy, the weaknesses are widespread, the weakness detectability is easy, and the technical impacts are severe. Then you go down to whether or not if the attack vectors are difficult, the weaknesses are uncommon, and they're hard to find, and the technical impacts are minor. Okay, so information for this session will come from the following sites and maybe some more. It'll come from Microsoft, come from the SDL Process Training, and come through the Agile SDL Process Training, and I have a page from OWASP. And here you can see the SDL process for training and the SDL for Agile, and we'll talk about this in just a bit. Microsoft Security Development Lifecycle is a commitment to understanding security basics, and the latest developments in security and privacy can greatly help organizations reduce the number and severity of exploitable software vulnerabilities and react appropriately to ever-changing threat landscapes. So the SDL Process Overview. Okay, so as you can see, there are several steps here. So we go from training to requirements to design to implementation to verification to release and response. There are a total of 17 different steps as you go through these phases, and I will be talking about each one of these. So SDL process training, so core security training. What this means is that all the members on your team need to be briefed on some sort of security training that is related to their company in some way, and that they have to go through training classes at least once a year but maybe more. So it's not just your developers, it's also your testers and your program managers or anybody who is involved in the project. So some Pluralsight training classes are below. I strongly suggest that you look at Web Security and OWASP Top 10. This goes through the OWASP Top 10 for ASP.NET, and this will get you started with the OWASP Z attack proxy for web applications, which is basically a attack tool that will go against your project and find issues. And we'll talk about this later. So SDL process requirements. What this slide is basically talking about is how you need to define your security requirements up front. Because if you do this later, this will create disruption to the project and will make the project go longer, which nobody wants. And you need to have all your security planned up front so that you can figure out how you're going to implement security in your project. And we'll talk about how to do this a little bit later. So basically, security and privacy requirements analysis is performed at project inception and includes specification of a minimum security requirements for the application as it is defined to run its planned operational environment and specification and deployment of a security vulnerability work item tracking system. Create quality gates and bug bars. Quality gates and bug bars are used to establish minimum acceptable levels of security and privacy quality. Defining these criteria at the start of a project improves the understanding of risk associated with security issues and enables teams to identify and fix security bugs during development. A project team must negotiate quality gates for each development phase and then have them approved by the security advisor, who may add project-specific clarifications and more stringent security requirements as appropriate. The project team must also illustrate compliance with the negotiated quality gates in order to complete the final security review. Perform security and privacy risk assessments. Security risk assessments and privacy risk assessments are mandatory processes that identify functional aspects of the software that require deep review. So some questions you might want to ask yourself are, such as, which portions of the project will require threat models before release? Which portions of the project will require security design reviews before release? Which portions of the project, if any, will require penetration testing by a mutually agreed upon group that is external to the project team? Are there any additional testing or analysis requirements that the security advisor deems necessary to mitigate security risks? What is the specific scope of the fuzz testing requirements? So things like threat models and fuzz testing and penetration testing we will talk about later in this video and videos to come. So let's talk a little bit about privacy impact rating. What is a privacy impact rating? The answer to this question is based upon the following guidelines. P1, high privacy risks. The feature, product, or service stores or transfers personally identifiable information, changes settings or file type associations, or installs software. P2, moderate privacy risk. The sole behavior that affects privacy in the feature, product, or service is a one-time user-initiated anonymous data transfer. P3, low privacy risk. No behaviors exist with this feature, product, or service that affect privacy. No anonymous or personal data is transferred. No PII is stored on the machine. No settings are changed on the user's behalf, and no software is installed. So let's talk a little bit about data types. Anonymous data is not unique or tied to a specific person, such as hair color, system configuration, or statistics distilled from many users. Pseudo-anonymous data. Unique identifier does not identify a specific person, but could be associated with an individual. This includes unique identifiers, biometric information, etc. Until associated with an individual, data can be treated as anonymous. Personally identifiable information, or otherwise known as PII. Data that identifies or can be used to contact or locate a specific individual. This includes name, address, phone number, email addresses, etc. Sensitive PII. Higher risk of PII includes medical, financial, national ID number such as social security number and or credit card information. Could also include data to discriminate, such as race, ethnicity, political, religious, philosophical, union membership information, and etc. Establish design requirements. The optimal time to influence a product design trustworthiness is early in its life cycle. It is critically important to consider security and privacy concerns carefully during the design phase. Mitigation of security and privacy issues is much less expensive when performed during the opening stages of a project lifecycle. Product teams should refrain from the practice of bolting on security and privacy features and mitigations near the end of a product's development. The design requirements activity contains a number of required actions. Examples include the creation of security and privacy design specifications, specifications review, and specification of minimal cryptographic design requirements. Design specifications should describe security or privacy features that will be directly exposed to the user, such as those that require user authentication to access specific data or use consent before use of a high-risk privacy feature. In addition, all design specifications should describe how to securely implement all functionality provided by a given feature or function. It's a good practice to validate design specifications against the application's functional specification. The functional specification should accurately and completely describe the intended use of a feature or function, describe how to deploy the feature or function in a secure fashion. Perform attack surface analysis reduction. Attack surface reduction is closely aligned with threat modeling, although it addresses security issues from a slightly different perspective. Attack surface reduction is a means of reducing risk by giving attackers less opportunity to exploit a potential weak spot or vulnerability. Attack surface reduction encompasses shutting off or restricting access to system services, applying the principle of least privilege, and employing layered defenses whenever possible. Use threat modeling. We will talk about this in a later video. Use approved tools. All development teams should define and publish a list of approved tools and their associated security checks, such as compiler linker options and warnings. This list should be approved by the security advisor for the project team. Generally speaking, development teams should strive to use the latest version of approved tools to take advantage of new security analysis functionality and protections. So below is a list of Microsoft Security Development Lifecycle tools. I do have one tool here that's not part of Microsoft. It's ReSharper. This is a really awesome tool that analyzes code quality and compiles with coding standards and etc. So I highly suggest that you use this tool as well. Deprecate unsafe functions. Many commonly used functions and APIs are not secure in the face of the current threat environment. Product teams should analyze all functions and APIs that will be used in conjunction with a software development project and prohibit those that are determined to be unsafe. Consider code scanning tools to check code, including legacy code where appropriate, for the existence of banned functions and replace those banned functions with safer alternatives. Perform static analysis. Product teams should perform static analysis of source code. Static analysis of source code provides a scalable capability for security code review and can help ensure that the secure coding policies are being followed. Static code analysis by itself is generally insufficient to replace a manual code review. The security team and security advisors should be aware of the strengths and weaknesses of static analysis tools and be prepared to augment static analysis tools with other tools or human review as appropriate. So down below I have Veracode. This is a very good tool, this binary stack analysis tool. So I suggest that you take a look at this. You can plug this tool into your code and it'll find issues and show you where to fix them in terms of security. Well, that's all that I have for now, and thanks for watching.